dinosaur noises. And there might be a question on the midterms, like halfway through the midterm, all of a sudden it'll just say, question number 4, stand up and make a dinosaur noise, and then I'll have to come over and sign off on it once you've done it. Huh? I will totally do that.
3 points.
Know what dinosaurs actually sound like.
I've seen the movies.
You've seen a lot of movies,
So you're saying the movies are accurate?
Of course. Name one movie that wasn't accurate. They're all true to life.
Vast majority of them.
Well, okay, a dinosaur-like noise, or a simulated dinosaur noise. Do you have a dinosaur noise?
Do I?
Yeah.
No,
Well,
but have you heard of the pterodactyl game?
the who?
The pterodactyl game?
The pterodactyl game. Is this
Yes.
is this along the lines of the make toast stuff?
No, but it can like be played in like a camp setting. So,
How does the pterodactyl game work?
so you're like standing in a circle and you're not allowed to smile. Simply, you like usually like have your lips over your teeth.
Okay.
And you have to say pterodactyl, and like it goes in a circle. Has anyone else played this game? Okay. And then if you want it to switch directions, the person has to like make a pterodactyl noise, and then it switches, and like you get people that will like keep doing the pterodactyl noise, and then it makes everybody laugh and then lose.
Okay, so what's your pterodactyl noise?
I don't know. I'm not gonna do that.
Well, you just dared me to do this on a test, so I'm doing it on the spot.
It's on the recording.
Yeah, it is recorded. At least I'm not making you come over like right in front of the computer and do it. Also, then what's going to happen on this midterm when I do put that question on there? Are you gonna chicken out then too?
No.
Oh, so you'll get up mid exam?
Yeah, because everybody will have to do it.
Well, they don't have to. They're just
Well,
sacrificing
they want the
points.
The question is, do you have to stand up or do you have to climb on the table?
Climb on the table.
Oh,
There could be 2 different tiers of points.
yeah.
Extra credit.
Normal credit is stand up and make the noise. Extra credit is get on the table and actually do like a motion-based impersonation. This is gonna the entire midterm is gonna just be like role-playing stuff. There's no programming questions on this whatsoever.
And we'll do the midterm in the cab.
It's a great idea. All right. That's great.
I actually feel like it would be better to do it in the cab because then there's already some white noise, so then it's not like in the middle of a quiet classroom that you have to do that.
Oh, really?
Yeah.
What if you have to do it like in the cap, but like up by one of the stations? So like not like
stand
at
on
some,
one of the stations.
well, not stand on the station. They probably have some like food safety things related to that, but like not at some random table in the middle of the crowd. Like maybe right by the
I think
desk.
so.
Maybe right by the desk where people are like swiping in,
You
like
send them
during the rush. If you go there for lunch today, we're gonna have our Now Robot by Gretchen at the desk telling Chuck Norris jokes. He should be there at 11:30ish or so. Will you hit the third button down there for the lights? He wasn't paying attention. Just third button now. You're good. Well, no, yeah, third button. That should go off. Thank you for your assistance, Jake. It's a teamwork. Charlie, do you have a dinosaur noise?
Probably the T-Rex.
You have a T-Rex? Oh, let's hear your T-Rex.
You don't want to see it.
No, I kind of do. I definitely do. All right, so what was the homework? We were doing shunting guard. Was it just to, so we already filled up our input queue. So, all right, so we had to fill up the output queue.
the input queue, the output queue, and the obstacle.
All right, well, we already have our input queue. That was last homework, right? Input queues filled
Then
up.
you had to change it into the reverse solution.
Right. So you have input queue, you have output queue, and you have op stack. So ultimately, the solution for this homework was output queue completely filled up and the other two things empty, right? And then you have your reverse Polish stuff. Okay, let's do that. Do we have any? We have an interface for this now, right?
It still wasn't working for me.
You went to one of the computers in the lab. I opened this code. I don't get it.
I can drop things in there, I just can't see it.
I know. I get what you're saying, but I mean, I literally downloaded my repository and opened it on those two computers, and I put that screenshot up. I mean, it worked on both of them. I don't know why.
It will work when you do another assignment. Not the same one.
Well, I did this one. I mean, this was the one I downloaded. I just don't get it. Is it working on yours again? One thing you might try, if you go to Android Studio, you go to Preferences. You go to
I got a project structure, file,
Well,
project structure.
no, the thing that I'm looking for is the current installed. Oh, I think it's under System Settings. Android SDK. So appearance, behavior, system settings, Android SDK.
Downloaded all that.
All right, so then make sure you have. So what's the most recent one you have installed?
Like fully installed, 'cause I got those partially installed. Like
Yeah, the partially installed ones.
I got Oreo 26 release.
Okay, yeah, so that should be
It might
fun.
just be like this program. So when I open up like the older ones, they still run fine. I don't know if I
So
just like when it forked, maybe it just lost something somehow. Try to set that up in project structure.
Yeah, because so what did you do? You went to File, Project Structure.
Yeah. And then go to app at the bottom.
Oh,
Yeah, and then you change the API right there.
all right. So try that. Does yours say API?
Yeah, what,
You says 8,
yeah.
just like that. I don't know. I mean, since I can't fork my own repository, I just downloaded the zip file of it on that machine down there and opened it from the zip file. And I went to Open Project, went to the zip file, and just I had already or extracted the zip file, and it opened just fine. All right, so why don't we do this? Let's solve this real quick, and then so you're having problems on that laptop?
Yeah.
All right, so let's solve this real quick and try to finish up maybe around 11. And then let's go down to anybody who's having problems with it. Let's go down to the lab. You bring your laptop. I want you to log into the machine you're using, and let's just get this figured out. Yeah, because I get why that would be frustrating, but I can't recreate it. Okay, so let's burn through this then real quick. What am I doing?
Speaking of standing at desks, I can see footprints on you.
Yeah, that's mine.
What were you doing?
Well, I had class last night, so I do some dancing. See, the problem is you're not 100% sure I'm lying. Right? You're like probably 80% sure that I'm probably making that up, but there's a chance.
And then
So it's more than a 20% chance that you think I'm.
it doesn't surprise me.
I know. I had to weight test these things. All right. So, what was I talking about? All right, let me run this real quick so I can remind myself what it currently does. I think we currently can add in, we put in our little bucket thing and hit the button, and then it what does it spit out to the? Doesn't spit out to the screen. It spits out to the log cap.
Mine's working, like I can now open it up. I don't know if it's just,
Had you tried it since there was an update?
yeah, but like my updates were even going through usually. They're just like stuck on patching.
So yours is working now with this same project.
I can open up, yeah, my device.
Okay. And but just yours still isn't working, so we're gonna still debug that. Everybody else has a project that works. You don't have a project that works either. All right. So at 11 o'clock when we go down there, everybody who doesn't have something that's working, come down there. We're gonna fix it. Is what we're gonna do. If I would have known we were gonna have these issues, I would have brought Mr. Gonzalez in today to help. Oh, you've all met Mr. Gonzalez, right? You just heard about him. You haven't really met him. He's been around. 123 plus 8 divided by 2 times 4, something like that. Hit click me, and we're spitting this out the log cat right now. Okay, so what did I put in there? $123 plus 4 times 9. 123. What the heck? Oh, disconnected. There we go. 123 plus 8 divided by 2 times 4. It keeps tricking me every single time. All right, so now we have that thing. So that's our input queue, right? So let's go look at the logic for that button so I can remind myself what that guy does. Where's my... On click me button pressed, we read in the stuff, we remove the spaces from it, then we call parse string toke, input et, blah, blah, blah. So here's parse string toke. So that's the one using the tokenizer. I showed you 2 different ways of doing it last class. All right, and this guy goes through and it throws all this stuff into our input queue called the queue. Let me show you something real cool, kind of real quick. So I'm gonna highlight this guy. I'm going to right click just so we have some naming stuff. And I'm going to do, we should have a thing in here called refactor. Where is refactor? Refactor. So I'm going to do refactor. I'm going to say rename. And I'm going to call this guy input queue like that. And press enter. And notice when I did, since I refactored it, I went to the original, I refactored it. It changed it every place else that I used it previously. Does that make sense? That's a software engineering thing called refactoring. You're all in 370 right now, right? You might not have talked about that yet, but it's just a change it once and it changes everywhere. It's a tool that's built into a lot of IDEs.
That's what I thought it should be too. You mentioned about input queue and output queue. We already have it. So I think that's
Yeah. Well, it was just called queue. That was the input queue. But now I've named it input queue. So now we're going to need a couple of other things. Now we wrote stack last time, didn't we? We wrote the op stack. So we're going to need a private op stack, and we're going to need a private queue, output queue, like that.
What we also need to push from the upstep. That was part of the homework.
Oh, we didn't finish writing op stack yet?
No.
Oh, we wrote it, but we wrote it the generic way, not the... Okay. Oh, this is the logic for whether you can add op node to the stack. Okay. So what we need to do is we need to go to our op nodes. And when we create an op node, we also need to then give an op node a, I don't know, what do we call it, a power? A priority? Okay. We'll call this guy priority, and this is going to be an int. Okay. So then inside here, we will look at our, so let me show you some other object-oriented programming techniques here. So I'm going to go ahead and I'm going to create a private static get priority priority given a char C. So, or we'll call this char op. So we're going to pass this guy an operator, and this guy is going to return void. Actually, he's not. He's going to return an int. All right, but I made it static. And the reason I made this static is every single instance of opnode doesn't need to have this method. We really just need this method once, where I can throw an operator at it and it spits back the numeric priority of that guy. So this actually saves a little bit of memory, because this is going to be, because it's static, that means it's a class method. We would call it by saying opnode dot get priority, rather than this dot get priority. So every instance of opnode would not get their own copy of this. There would only ever be one copy of this function, right? But every opnode needs this ability. That kind of makes sense? It wouldn't be a deal breaker if you didn't make this guy static, but if you're writing it correct, if you're writing correct object-oriented code, you'd make it static just because you don't need multiple instances of this. So we'll pass it the op. We'll say if op is equal to plus or op is equal to minus, what's the priority for those two? Doesn't necessarily matter as long as it's less than the, so we'll return 2 for that. Not return, yeah, we'll return 2. Else, in our code here, it must be multiplication or division because we're only supporting those 4. So we'll return 3, like that. Multiplication, division are tied with each other, but they're a higher priority than addition and subtraction. So does this look like it sets priority accurately? All right, so then what we'll do here is in the constructor for this guy, we will, this is up, no, oh yeah, so my payload is my operator. So we'll say this dot priority is equal to opnode dot get priority and passing it this dot payload to generate the priority for whatever that payload was. All right, so now I just taught all of our opnodes how to internally set their priority depending on which operator I sent them, assuming we're only supporting plus, minus, times, and divide. Okay, that makes sense? And then I'll go ahead and give myself a getter for priority so I can ask the peak of our stack about that dude. So I'll generate a getter for priority. Perfect. All right, questions about what we just did with opnode? Pretty straightforward. All right. I doubt any of you did it this way because I don't know if I've introduced that idea before. I mean, we knew about class static versus non-static methods, but maybe it's still a little fuzzy when to use one versus the other. It's probably not a real common thing. We'll call this the appropriate use of it, but at the end of the day, it doesn't really matter. Okay, so now you said I need to finish writing my push. All right, so push is going to, now we need to make a decision here. We can decide whether or not we are going to allow it to be pushed externally to this. So, you know, when we are processing our input queue, when we look at the front of it, if it's an operator, we can then ask the question, am I allowed to push it now, or do I need to change my op stack? So if we decide to go ahead and do that externally, then push here becomes pretty simple, right? Push is just add front without any sort of extra logic or something like that. Now the alternative is we can let our op stack decide whether something is legal or not. Okay, so what we can do is we can say, go ahead and push to this guy, and we'll give him the value to push, and he's going to be pushing in a op node. And we can continue to try to push it onto the top of the stack, but he might kick stuff out to our output queue. So maybe we'll go ahead and give this guy the output queue as well. So I'm going to say, let's try to push an op node called op. And we're going to give this guy the output, or this is the queue, output queue as well. So he's going to have both of those pieces. Okay? And what he's going to do is he's going to clear this op stack until he's able to push the thing to the top. All right, so we're going to say while this dot peak is not equal to null, so while there's something there, and this dot peak dot get priority is, now we're always allowed to put a higher priority on top of a lower priority, right? So while the current top of it has a greater than or equal to priority to op.getPriority, the guy I'm trying to add. So as long as there's something at the top of the stack and the thing that's at the top of the stack is preventing me from pushing this new guy in, right? Which means the guy I'm trying to add, op.getPriority, is less than or equal to the guy that's currently at the top of the stack. Okay? Because it needs to be less than in order for me to push it. Correct? So if that's the case, I need to clear at least the top of this. So I'm going to say output queue dot enqueue this dot pop. And this dot pop. Oh, well, doesn't it take a, what does enqueue take? Oh, enqueue takes a payload. Okie dokie. All right. So
We should make a version of NQ that takes in a node.
that would probably make some sense. So we can use polymorphism here and say that we have a version of enqueue that takes in something of type node and goes ahead and adds it. But, you know, what we have here already works, so we'll just roll with it. It does make the correct type of node out of this. So we're being a little inefficient by, we have an op node, we're going to break it down to its payload, pass it into the queue, create a new op node from it, add it to the output queue. But it'll work. Heck, whatever. We'll just write it. So public void enqueue. This guy will take a op node as a parameter. Op. And we'll say this dot enqueue, because that one is a private one that takes the node, right? Oh, that's the one that came from node. No. There's DQ, there's NQ payload. Oh, there's the NQ that takes in a node, and we made that guy private. So we'll say this dot NQ op. And now we can throw an op node in there. So this, all this guy does is prevents us from creating a brand new op node to wrap a payload, because we already know that what we're getting off the op stack is an op node. So now I don't need to say .get payload here. All right, so if I cannot push the value that I currently want to push, if I can't push my op onto the top of the op stack, because the top of the op stack is a thing, and that particular thing has a priority that's at least as big as the thing I'm trying to push, then I need to pop that guy off, add it to the end of my output queue, and then spin up and try again. When I'm done with this while loop, I know that my op stack can now accept the this new thing. All right, so we'll ask the question, if this dot top is equal to null, then we'll say this dot top is equal to output queue. I'm sorry, this dot top is equal to op. Else, there must be something that's actually there So I'll say this dot op dot, not this dot, just op dot set next node to whatever top points to, and then set this dot top equal to op. So that'll push it to the top of the stack, but only after I've cleared the stack to the point that it's allowed. Make sense? Any questions on this? So this logic is clear the stack until it is a legal move, then push op onto top of stack. All right, so that is push. So now whenever I go to push something, I'm guaranteed for it to work eventually, right? I'm going to throw it at push. I'm going to pass it the operator I want to push as well as my output queue, and he's going to do the job of throwing the stuff into the output queue if necessary. Okay? Now, because I'm going to need it, I'm also going to go ahead and I'm going to say public void clear op stack, because we're going to need that at the very end. And this guy's job is to just go through and pop everything off the op stack until we have nothing on there, nothing left in there. So we're going to say while this dot top is not equal to null, as long as I still have something at the top of the stack, I'll say, and this guy needs to take our queue, output queue as a parameter. So we'll say output queue dot enqueue, and this guy will take in an op node, and we'll say we're going to enqueue this dot pop. We'll keep doing that as long as this dot top is not equal to null. As soon as it becomes null, that means we know we have an empty stack. All right, because we'll need this at the very end after we've cleared out our input queue to ultimately push the last operators onto our output queue. Okay, so now let's go back to main activity. So here is our parse string toke. So this guy ultimately filled up the output queue. So if you wanted to, you can right click on this, say refactor, rename, and we can say fill output queue. All right, because that's really what we're doing. I'm sorry, it's not fill output queue, it's fill input queue. Rename it again, because that's what we're doing there. We are filling the input queue. Okay, so the very first thing we'll do is we'll fill our input queue. Then we need to start processing the input queue. So we'll create a function in here, private void process input queue. And this guy will keep working through the input queue until we're out of stuff in there. Let's look at our queue real quick. Do we have an is empty? Yeah, we have an is empty. That'll tell us whether or not it's empty at this point. So process input queue will say as long as there's something in there. So while this dot input queue dot, well, that guy is not empty. As long as there's something still in there, we're going to dequeue the thing that's in there. So we'll say node n is equal to, actually we'll say node cur node. And then we'll say cur node is equal to this dot input queue dot dequeue. And that guy did give me a node, correct? Yes, he gives me a node. All right, so now I have a node called cur node, and I want to know what kind of node it is. If it's a num node, I can just immediately enqueue it in output queue. right? So if cur node is an instance of num node, if he's one of those dudes, then we'll say this dot output queue dot enqueue. And we really should write a similar version that we did before in our queue. So we'll do an enqueue for a num node. So we'll say this dot enqueue, and we'll pass it our cur node. Now, right now, this guy is saying, I don't know how to send something that's a node. Now, we happen to know that this guy is a num node. So we can cast him to num node and say, that's what we're passing in there. He's definitely a num node. How do we know? Because we just asked the question, are you a num node? Else, he must be a op node. And what do we do with op nodes? We push them onto the op stack. So we say this dot op stack dot push. And we need to give this guy an op node. So we're going to give him the op node version of cur node along with the current output queue, this dot output queue, for him to do his job. Okay? So we'll go through our input queue until it's empty. Each time through, we'll grab whatever the first node is. We'll dequeue it. If it's a num node, just throw it on the output queue. If it's an op node, push it onto the op stack, and we just wrote push to clear the op stack as necessary to allow the push. Finally, when this guy is done, we'll say this dot op stack dot clear op stack, and we'll give this guy the output queue. That'll do the final piece of that, right? Okay. Now, do we output queue? Did we do give this guy a display? How did we display this before in our toke thing? We just write a loop to spin through it. Fill input queue, parse string, test queue. All right, so test queue right now isn't taking. So here, we'll go ahead and say this guy takes in a QQ. So we'll have him work on anything that's a queue. So there's our input queue for that one for testing. And then we'll go ahead and we'll set this guy up for our output queue, this dot output queue. Okay, so when we click our click me button, we'll first fill the input queue. Then we'll say this dot process input queue. And that guy should clear the entire output queue or input queue, ultimately filling the output queue with our op stack being empty, because we're at the very end, we're clearing the op stack. Okay, and then we'll go ahead and test our work by saying this dot test queue, this dot output queue. So we want to see what the output queue looks like. Okay, so let's go ahead and run this guy. So we'll do 123 plus 4 divided by 2 times 5, something like that. So let's ask ourselves what this should look like. So before we do anything else, let's open up our, I don't have Keynote open. CSC300. All right, so actually we used this function last time, so I'm gonna actually type this one in. So 8 divided by 2 times 3 plus 7. So this should ultimately give us an output Q of 8, 2 divide 3 times 7 plus. All right, so 8 divided by 2 times 3 plus 7. Click me. Wasn't happy about something there. Failed binder transaction. Transaction too large exception. Okay, so our NQ function has looks like it's an infinite loop in it. Stack Overflow. Where did that come from? Click handler. All right, well, looks like we're going to have to hunt for it ourselves. Just for the sake of argument real quick. Eight divided by 2 times 3 plus 7. Okay, so that guy, oh, so he's crashing already. So we've done something bad even before, oh, unless it's our test queue. Can I copy this? Will it paste it in? Nope. 8 divided by 2 times 3 plus 7. I think we broke our test queue, which is the good thing for us to break. Probably didn't do something right when I generically made it generic. 8 divided by 2 times 3 plus 7. Who knows? It's actually in our fill input queue. Well, I guess let's confirm that. It has to be in there, but before we go dancing around. Eight divided by 2 times 3 plus 7. All right, yeah, that guy does not crash. Fill input queue. This might have something to do with our new functions for our pushing op stacks, tokens. Fill input queue, tokenize it. That should all work as long as we have more tokens. Do this. If it's an op, NQ, the integer version of that guy, else NQ, the char version of that guy. Here's our Q. If it's a char, we're building a new op node. We're NQing it. And that's going to call, oh, that's very interesting. So what we're doing is we created an infinite loop. So we're calling NQ of our op node. Yeah, see, this was a horrible idea. So we have a public function called NQ that takes an op node as a parameter. We also have a private function called NQ that takes a node as a parameter. Well, when I create my op node here, I'm creating an op node, I'm calling NQ on that guy. It's then calling this version of it, which just keeps calling himself over and over and over and over again, never actually NQing it. Because he was relying on this guy here, this NQ, to finally do the work. I can probably cheat this. I'll say this guy's going to be a node for a second. That'll throw it onto the queue the right way. And then here, for the one that takes a num node, this guy's going to be a node for a second. So by doing that, we force it to call this version of NQ, the one that just takes a node as a parameter. Okay, do you see why we were getting an infinite loop now? Yeah, we were doing no logic. We're just telling this function to just keep calling itself, and he does nothing but call himself. Very, very interesting bug. So let's go back here now. Clear those things out. Run. Yeah, that's why we do it. That's probably the thing you need to practice the most, especially at this point, because you'll do something that you think looks reasonable, and then you wonder why it's not working. 8 divided by 2 times 3 plus 7. Continue. Okay, so where did this guy crash? Let's make sure our original thing works again. Eight divided by 2 times 3 plus 7. All right, so he still works. Oh, but we're currently not displaying. So let's make sure that our test output queue is still functioning. 8 divided by 2 times 3 plus 7. Okay, that's where we're dying. Good place to die. So test queue takes a queue as a parameter. While the queue is not empty, we'll dequeue the queue. If n is an instance of num node, then we will give ourselves the num node version of it and then get the payload. Else op node is equal to op node. And then we'll get the payload from that guy. That looks reasonable to me. So where is this dying in there? All right, doesn't like is empty on null object reference. So is empty from our queue returns this dot front equal to null. So that means that our DQ So DQ can sometimes give us a null. Otherwise, if there's something in there, we'll grab the front. We'll reset it if that makes it the empty list. Otherwise, we make the front point to his own next node. Disconnect that guy. Node to return. That looks reasonable enough. So let's go into our main activity here. I'm going to put what's called a breakpoint here. And I'm going to run this guy in the debugger. So here's a little debugging tool. We'll hit play. Bring that up, bring that up. 8 divided by 2 times 3 plus 7. Click it. So now it's gone ahead and it's already done the original thing. All right, so this guy says the queue that I passed it is null. So he's dying right off the bat. Down here we can step over. Here's step over. Step over. So that's where it's, so I'm passing it a bad queue. So right off the bat here, whatever I gave this dude was null. It said queue was null. So fill input. This is fill input queue. Oh, I'm sending it the output queue to test it. I should send it the input queue to test that guy instead of my null queue. Also, that then reminds me, I never actually initialized my op stack or my output queue. The dumbest mistakes I could have made. So this dot output queue is equal to new queue, like that. This dot op stack is equal to new op stack, like that. When I created those, I should have initialized them right away, so I had empty guys anyways. All right, so now I can go ahead and run this dude normally. Eight divided by 2 times 3 plus 7, so that should work this time. There's our output there, and then we will process input queue. Run this again. Eight divided by 2 times 3 plus 7. Click it. Oh, I'm never, well, I am testing it. Should get 2 different outputs there. I'll just say not to test it there. That way we just see the output queue version. 8 divided by 2 times 3 plus 7. All right, so 8, 2 divide 3 times 7 plus. 8, 2 divide 3 times 7 plus. All right, so that guy's filled up with the right stuff now. Very interesting. Actually, this was a good example because really all the logic we wrote was completely correct. Our mistake was the stupid mistake of never initializing our two variables here. And then that became exacerbated when we tried to print out a null value right here. We tried to test it with the null value because I had never initialized it. So I was passing it the wrong queue anyways. I was passing it the output queue, thinking that was the guy I should have been testing. But I was actually passing him the null version of my output queue because I never initialized the variable. All the other logic was okay. All right, so questions about that. So now our very last step would be to then process the output queue to give an answer, right? So we're going to have a void process. We can make it private. Process output queue. This guy should ultimately show the answer on the screen. If you want to do this just to logcat, that's fine. Otherwise, probably put a text box on your output. So this is us processing that output queue, which we did at the end of class last time when we just did the math. Make sense? This is processing that stack. All right, so over the weekend, do that. I will go ahead and push this. And then those of you who are having issues, so let's see, solution up to filling output queue. Follow me down to the lab and go ahead and get logged into whatever machine you've been using, and let's figure out what's going on with that. Okay, so go ahead and head down there and get logged into your machine and